All right, so let's start talking about Java. So you write source code, right? Code containing Java commands. You put it in a file named something.java. The extension is critical. So this has Java code in it, whatever that means. And just like C, we need to compile this. So we compile using the command javac instead of gcc. And this gives us something called file.class, usually. And this is kind of like object code, but it's officially called bytecode. And to execute bytecode, we just use the command java. And that runs it. So it's a similar tool flow to what we do with C. We write our source code, we compile it, and then we execute it. Same thing happening in Java. We write our source code, we compile it with javac, we execute it with Java. So who here has worked with Java in some way, shape, or form already? Good number of people, cool. All right, so if you've done anything with Java, you've got any exposure to it, what is Java? How would you describe it in like one sentence? A what?
Cup of coffee.
Cup of coffee, definitely.
Exactly, that's it.
What else?
A high-level language.
It's a high-level language. Program that autocorrects for you.
That's only Eclipse that does that.
That's some of the tools like Eclipse that will do that for you, but you can actually get Eclipse to do that for C also. Yeah, I didn't tell you. I forgot to mention that last quarter. But along those lines, let me put down a possibly loaded term. Let me just say it's modern. Right? Things like autocorrection seem kind of modern. So a friend of yours who knows C comes up to you and says, so I keep hearing about Java. What is Java? Right? What might you say to them?
Thing that always tries to install a Yahoo toolbar.
Does it?
Yeah.
Something like that.
You're not getting Java from the right place. Yeah.
Object oriented.
Yeah.
Sorry.
So Java is object oriented. That's the one we're going to spend 10 weeks on, really. What else? Yeah. Many libraries. That's actually a huge part of this.
Cross-platform and pretty portable.
Okay, portable.
So much everything we could buy that you'll ever use.
Mm-hmm. Most of you have it in your pocket right now. Most cell phones are built on top of Java.
Is it interesting that it's usable both as like a front end, like application heavy code as well as kind of back end web development?
Yeah.
Or versions of Java.
Yeah, it gets applied in lots of different areas. The only place it doesn't really get applied, I think, is scientific computing. but front end, back end, hardware control. Who's doing the brain scan project? Are they in here? I think they're in the other section.
It's in the other section.
Yeah, David, yeah. That thing comes with a Java interface, which is kind of cool. Hook your brain up to Java. Well, let's drill down into some of these. Let's start with portable and cross-platform. I mean, C is standardized, right? It's a well-defined language. We can write a program in this class in C and take it to the other side of the world and find a C compiler, and it will probably compile it and it will probably do the same thing, right? But here's the thing about C. If I write a C program on the Linux server and I compile it and I get an executable a.out, and I copy that over to a Raspberry Pi and I say a.out, it will give me an error. It'll say invalid format. So the actual runnable program on an Intel-based machine is not usually runnable on an ARM-based machine like Raspberry Pi. Or if Apple comes out with their own processor again, which they're talking about doing for future offerings, it may not run that executable program directly. So the actual runnable programs that you write in C don't transport from one machine to another. That's not a problem with Java. In Java, I can write my program on my laptop, I can compile it with the Java C command, and I get a class file. I can copy that class file over to my ARM processor, Raspberry Pi. I can copy it over to my Java system on my cell phone. I can copy it to any system that understands the Java command, and I can run that program, and it'll run. So very, very portable. Part of the reason for the portability is because when you compile your program, you end up with this bytecode, these ones and zeros, but those are not the ones and zeros that your CPU understands. So we're not compiling down to machine code in the same sense that we did with C. We're compiling down to this bytecode, which is the machine code for a virtual machine. And it's a machine called a JVM. That's the Java Virtual Machine. And it's a make-believe thing. It's an imaginary piece of hardware that understands these ones and zeros that we call bytecode. But it's not actually a physical machine. It's a program. It's a program that's interpreting the bytecode and saying, hey, here's a 1001, that means I'm supposed to do such and such. And then it does such and such. But what this means is that as long as this laptop has a JVM program on it, I can run my Java code. And if my phone has a JVM on it, I can run my Java code on my phone. And if my PIC processor has a JVM on it, I can run my Java code on a PIC processor. That's where the portability comes in, because you're compiling down to this bytecode which runs on a JVM, and this JVM is actually a program running on whatever your native CPU is. So what's the computer science-y term for this sort of execution model? There's compilation, but there's something else, which is what this is. Say again? It's related to linking. Interpreting, yeah. So Java is interpreted. Right, so C is compiled, Java is interpreted. MATLAB is interpreted. You can write a MATLAB program, but the CPU doesn't know what it means. You run a program called MATLAB, you give it your code, and it figures out what you're trying to do. Python is usually interpreted, shell scripts are interpreted, Java is interpreted. Okay, is this a good thing or a bad thing? I mean, it's a good thing because of portability, that's what we were just saying, right? So there's a benefit, which is portability. But is there a penalty for that? Speed. That's probably the biggest downside. It's going to run slower in general because we have this layer of indirection here. We've got our binary code, but it doesn't go directly on the CPU. We've got a JVM running on the CPU, and the JVM's interpreting the bytecode. So side by side tends to be slower than a compiled program. And that was a big issue when Java first came out. There were reports it would run 10 times slower than a CPU. Well, a fast CPU might have been 100 megahertz. right? So 10 times slower is a big deal. Today, it's not such a big deal. So Java is used in lots of critical applications, and yeah, it's a little slower, who cares? So I switched all of my simulation stuff over to Java years ago because of the portability, because that was so beneficial, it outweighed the speed penalty. Any other benefits? Yeah, go
I
ahead.
actually have a question
Yeah.
relating to that. So like a company, would they run C code on things they want to run faster than Java on everything else, or is it all Java now? Usually
Is a really interesting question. There was a period of time when if you wanted to do like really fast scientific calculations, you used Fortran, because Fortran had been around longer and the compilers were better. They'd been so tweaked for speed, and that was the go-to language. C caught up eventually, but probably you're still going to use something like C for really, really hardcore number crunching, but it kind of depends. Where your trade-off is, because maintainability is another big issue, right? And Java tends to be in some ways more maintainable, and that can be 90% of the cost of your project is keeping it running after it's already been written. So there's no clear answer, but yeah, in general, speed would probably take you to another language. Yeah.
Is C++ compiled?
C++ is compiled.
And like in 215 when you had us, there was the last one you said we could write it in C or C++. I
Mhm.
looked at it a little bit. And it seemed like it was really similar to C, but it also has that object-oriented component, so it's
Yeah.
similar to Java now.
Mm-hmm.
So I feel like for an answer to his question, C++ would probably be the
Yeah, so there's other ways to get objects besides Java, right? And C++ is a very old object-oriented language. My personal experience with C++, I never really got my brain around it, because it would start to make sense, and then I'd say, oh, so I should be able to do this, and it's like, oh, but you can't do that. You got to do something special there. So it's like trying to learn English, right? There's all these like special cases and special rules. I imagine in some mindset it makes perfect sense, but it was frustrating enough for me that I walked away from it several times, and then when I got to Java, first time I looked at it, it just clicked. Like everything I wanted it to do, it did, and it did it exactly the way I imagined it should, and that just kind of pulled me in. And it's partly because it was developed, you know, after people had been using other object-oriented languages for so long. There was a chance to do it, I don't know, a little more right maybe. But yeah, so if you wanted modern options, there's more than just C or Java. But a lot of people go Python these days. A lot of businesses and other endeavors have gone that direction as well, and that's object-oriented and borderline functional. Here's another idea about interpreted languages, potentially greater level of security. Not always, but the idea is you can write anything you want in Java, right? Destroy the planet .java and compile it into bytecode. That bytecode never touches the CPU. It never touches anything on your system except what the JVM decides to touch on its behalf. And if you have proper security in this JVM, this virtual machine, you can constrain what your Java code can do to your system. So the idea of sandboxing, of running this thing in this virtual machine that controls access to the outside world, is potentially compelling in terms of security. Now, can you write a Java program that erases your file system? Sure, it takes about 5 lines of Java code. But I mean, it takes the same in C, right? And it takes 1 line in a bash script. But there's potential greater security here because you have this virtual layer in between what's happening and the actual hardware at the lower level. So security was part of what went into the development of Java. And along those lines, the way that they manage memory is going to be very different. They do most of the memory management for us. So we don't do mallocs, we don't do freeze. And so things like buffer overruns are harder to bump into by mistake, right? Or trying to access a memory location you don't have access to. It's harder to accidentally do that in Java. So it takes care of a lot of that stuff for us. Many libraries. So a big part of Java is about code reuse, right? Somebody writes a piece of code to do something. I mean, how many bubble sorts have been coded in the history of humankind? I don't know. It's probably a lot, right? I mean, probably everyone here has coded a bubble sort. And I've certainly coded them outside of a classroom. How many linked lists have been implemented by people, right? And it's always the same code, right? Here's a node and the pointer is null because it's a sent null and blah, 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 right? So part of the idea of Java is there's all these libraries. That there's a linked list library. You want a linked list, you just grab one from the library, right? So code reuse, not reinventing the wheel. And that works really well for programmers because if you want to write a program to create a tic-tac-toe game, you don't want to spend half your time making a binary tree package or a hash package or a linked list package, right? Those things exist. You grab them and you use them. So we're going to do a lot with code reuse, and this ties into the whole idea of object-oriented programming. We're going to talk about objects next. But the idea is that there's these pre-existing structures, these things called objects, that do all this heavy lifting for us. And we don't have to continually reinvent the wheel. We can just grab something that does a particular task and use it. And then we get to put these pieces together to do whatever our particular program is supposed to do. So it's a pretty fun environment to work in. All right. First year of writing Java code, I had one of these files and I just like saved a million copies of it everywhere. And every time I wanted to write a Java program, I'd grab this and I'd start editing it. So then I started teaching Java, so now I memorize this. So here's a typical main program, right? This is like your ODP 300. So Java C to compile it. Hey, no errors, first try, good. And if you look now, I've got a new file, mymain.class. And if you try to VI it, it's just gibberish, right? So it's got some readable stuff, but it's mostly just that control @ sign is usually a 0 and control B is a 2 and so on. So that's what it looks like in Octal. It's pretty short, right? And if you want to run it, we can just say Java and the name of that class file, but without the dot class, and it executes your program. Right, if you try to Java C with just the file name without the .java, you get an error. The error sounds much more complicated than that, though. And if you try to Java mymain.class, you'll also get an error. So there's a bit of asymmetry. When you compile, you have to say filename.java. When you run, You just say just the file name without an extension. All right, so what the heck is going on here? Without getting too heavy into objects yet, we're defining something like a structure in C. Okay, in C the keyword is struct, in Java the keyword is class. But a class is kind of like a struct in C. It's a collection of things that we're going to call, in this case, my main. And I could have called this class anything that I wanted. I could call this class elephant. But if I try to compile it, I'm going to get an elephant.class. So if I was going to call this elephant, I would prefer to put it in a file called elephant.java. But anyway, it's a class named elephant, and if I want to execute that, I can just say Java elephant, and it runs my program. So the class name is not really critical. Here's what's critical in a Java program, this word main. Okay, that tells it that this is a main program that I'm writing. And it's just like the keyword main in a C program. If you write a C program and you call your main program something other than main when you try to execute it, actually when you try to compile it, you'll get an error saying there's no main that it can find. So we've got to have this thing called main. Void is the return type. So in C we can make a main that returns an int, we can make a main that returns nothing, we call it void. This is a void main, there's no return value coming back from this. Public static we're not going to worry about. Okay, that's going to be a while down the road before we get to those. Public basically means that I want things outside of this file to be able to access this program called main. And static's going to take a while to discuss. But this is boilerplate. Public static void main, that's always going to be 4 words separated by spaces that you use for your main program. Followed by parentheses, followed by this string bracket bracket args. This takes the place of argc, argv. So here's one of the nice things about C, about Java. There's a variable type called string. And if I say string s, that's it. S is a string.
What a novel idea. What a novel idea.
What a novel idea, right? So we can store characters in S, right? And it'll remember them. And there's no null terminator. There's no array of characters. There's none of that stuff. Okay, it's an actual type of variable called a string. And there's also arrays. So there's integers. So here's an integer called x. If I want an array of integers, I can say integer bracket bracket x. That's an array of integers.
You don't have to specify a size first.
Eventually you do, but to just declare that this is an array, we just say bracket bracket. So when we say string bracket bracket s, what are we saying? S is an array of strings. And that's exactly what we want to pass to a main program, is an array of strings. That's the whole argv thing from C. But because C doesn't really understand arrays very well, we also need to tell it how many things are in there. That's why we pass an argc. Okay, we don't need to do that in Java. We just say args is an array of strings. Args could be anything we want. It's just a variable name. But it's got to be string bracket bracket. So that first line, public static void, main string bracket bracket args, is kind of boilerplate. Yeah?
The S in string has to be like capital S or...
The S in string has to be capital, yes. So everything in Java is case sensitive, and if we want a string, it's an uppercase S on string. Suspiciously, if we want an int, it's all lowercase. We'll see why later.
When you try and compile it, or when you try and compile it, will it tell you the errors that the S in the string isn't capitalized?
Yeah, so let's do that. we'll compile that. It'll say error cannot find symbol, and it points to the word string.
So considerate.
Yeah, I know. All right, so that first line is basically how we're going to always write a main program. You can call it something different from args, right? But public static void main string bracket bracket and then some variable name, close parenthesis, and then a curly brace. Curly brace begins and ends blocks of code. And so this Java program called main has a single line to it, which is system.out.println and then a string. And this is basically a function call. But it's a very different kind of function call from printf, for example. And we don't really need to get into a lot of details yet about what this means. Just think of this as the name of the function, capital system.out.println. And it says take whatever we have in there and print it out. But it's a whole lot nicer than printf. Because we can do things like this. Not quite like that. So I can say print line x plus, quote, times 2 equals, quote, plus y. And that plus means put these things together, concatenate these strings. So I'm asking it to print out the value of x followed by times 2 equals followed by the value of y. And so it prints out 10 times 2 equals 20. So here's a place where 224 might make your life easier. Because every time I want to compile my program, I've got to say java c my main.java. And every time I want to run it, I've got to say java my main. You could make yourself a script. Probably be one line of bash code that does this for you. So make a script. I usually call mine C for compile. And you can be fancy. You can see if $1 is equal to blank, and if it is, tell the person how they should use the C command. Otherwise, say java c $1.java. And then I have a command R for run, which just says java $1. And so now I can say C space my main, R space my main. And if I want to do it again, I can say exclamation C to pull it back, and so on and so forth. So don't forget that you've learned all this Linux, right? and shell scripting and things like that. Make your life easier, right? And we're working in a Linux environment for the first 3 weeks anyway. Go ahead and customize it. Make things good for you. All right. Questions so far? So I have a link here on Canvas for Java documentation, and go ahead and link through to it, click through to an external site. And this is sort of the origin of Java documentation, right? So oracle.com is Java, who, by the way, just won a huge judgment against Android, Google, claiming that Android is using proprietary Java code without permission. So that's evolving presently.
Doesn't it date back to a time when it was Sun Microsystems running the whole thing?
Yeah, so Java started at Sun.
Yeah.
In fact, they made a Java ring when they first. You can still find these on eBay occasionally. It was a ring that had a little Java machine inside. They're pretty precious now. But yeah, it was the idea that Java was going to be embedded. You're laughing at my 250 slide?
That looks about right.
Yeah, pretty much. All right, so Java Oracle site with an annoying pop-up. There you go. So you're probably interested in core APIs, and version 8's the modern one, so we're probably going to use that. So you can click through to the API doc. And this is what all Java documentation tends to look like. And if you use this self-documenting feature of Java, where you can run the javadoc command, this is what it produces. Okay, same look and feel, same setup, and so on and so forth. And it has a search option. It has an index. So let's see. Oh, that's handy. Sweet. Okay, that was just a glitch. Yeah, this is not the optimal way to do this, but well, let's go ahead and look at string. I'll just click through on it. All right, here's a class string. So if you're playing around with strings and you want to know anything about strings, you can find it in this documentation. Okay, this is in some sense the source of all this stuff. So we can say string and the name of a variable, and we can say equals double quotes and list a bunch of characters, end quote, semicolon, that defines a string named str equal to ABC. But there's other ways you could do it. You could set it up as this array of characters if you really wanted to. You can set it up as string str equals new string, that array of characters. That's not very convenient. You can do concatenation, right, like this. But once you have a string, you have more than just a set of characters stored in memory. You have what are called methods. Methods are just a fancy word for functions. You have all these things you can do with strings. For example, I can say, I want to see the substring between characters 1 and 2. Or you can say, I want to know the length of this string. Or you can say, I want to convert this string to uppercase. Or I want to compare this string to a regular expression and see if it matches. Or I want to concatenate this string to another string. There's lots of things you can do once you have a string. And so there's a list of all these methods. Show me the character at some particular position. Compare this string to another string. Concatenate to another string. Tell me if this string ends with a particular suffix. Okay? All of these things are different methods that you can apply to a string. Yeah.
So is the S capitalized because it's a class? And
The S is capitalized because it's a
everything else
class.
is just data types?
Right. So this brings us to another point. There's a lot of conventions in Java. And conventions are not part of the language per se, but they're things that most people do, at least today. And it's a good idea in general to try to stick to these conventions. One, because if you're in a job interview and you violate these conventions, they're probably going to get you dismissed from consideration. Not always, but right? It's going to be assumed that you don't have a lot of experience with what you're talking about. But two, if everybody follows the same conventions, it makes it easier to look at someone else's code and gain an understanding more quickly of what's going on. So some of the conventions are when we have a class, something like a string, it starts with an uppercase letter. When we have a variable, it'll usually start with a lowercase letter. Another convention is to use what's called camel case. How many people know what camel case is? Right, so the time of day, that's snake case. You just put underscores in between. And that's because in a lot of languages, uppercase, lowercase variables mean the same thing. Camel case, you would usually write something like the time of day. Right, and you uppercase the beginning of each word in your variable name, but not the first one, because there's this convention that variable names have lowercase letters. So we're not talking about so much stylistic points, where do you put the curly bracket, how much do you indent. We're talking about more things related to the structure of the program itself. So we'll talk about these conventions as they come up. All right, so I want to look at this idea of all these methods, these functions that go along with a string. There's a length and so on and so forth. So there's a string. Hello there. And I can print it out with the same print line statement. Here I'm printing out the words str equals and an angle bracket, and then I'm concatenating str in the middle, and then I'm printing out a closing angle bracket. But let's also print out its length. And this is how I'm going to find the length of this string. I'm going to say the name of the string, str, period, and I'm going to say length. And how do I know I can do that? Because str is a string, and in my documentation it tells me there's a method named length. It returns the length of the string as an integer. So this should tell me the length of the string is, and then tell me how many characters are in there. So there's my string, and the length is 11. And there's no new line on the end. There's no null terminator to worry about. It's just a string of characters exactly the way you set it up. So let's talk about these methods. So a method is a function. And let's say I have a string str, which is equal to something. And I want to know what the length of that string is. Well, here's how we would do this in a non-object-oriented language. We would say something like, I equals length of str. In C, it would be I equals string len of str. Right? We have a function, and we pass our variable to it, and it returns an answer to us. Okay, that's C-like. Now, we know that a structure in C or a class in Java, right, we can put multiple things into that. We can have a structure that contains 3 integers and a string, right? And in Java, we could make a class that has 3 integers and a string. And if we want to get to that first integer x, we could say variable name dot x, right? Forget about the arrow with the dash greater than sign, right? If you have a C structure and it's got a field named X, you can say variable name dot X, that gets you to that field, right? If you want to get to the structure called time, you can say variable name dot time. Well, here's the thing with these structures in Java, they don't just contain variables, they also contain code. So str is an object of type string, but it contains a bunch of code inside it. One piece of code contained in this object is a function called length. And if I want to run that piece of code, I can access it by saying the name of the variable dot length. And I put parentheses to indicate it's a function as opposed to a variable. Now here's the weird, go ahead.
I was gonna say, so it's not like, so like in C structures, if you got a component for this string called length, then it would just be like an integer.
Mm-hmm.
But you're saying that this component is a function?
Yes. So it could contain data fields like an integer or a double or things like that, but it can also contain fields that are actually code, actual functions.
So all these variables are inheriting all these functions from.
Yes, yes. And here's where it gets a little weird. Because when I call this function length, I don't give it an argument. I don't have to give it an argument. How does it know what I wanted to take the length of? Because I called this as a field of this variable str, it's going to work on this variable, this string, and return its length. So let's make something new in here. All right, so quick code. 3 strings S1, 2, 3, I initialize them with given values. And now I'm going to run the same print statement, but I'm going to call S1.length, S2.length, S3.length. Right, length of S1 is 5, length of S2 is 2, length of S3 is 0, which is what we would hope would happen. So it's the same function length in each case, but because I'm invoking it as a field of S1 or S2 or S3, it's going to operate on either S1 or S2 or S3 and return the length of that corresponding string. Yeah.
I was wondering how you could edit the code where it says S1, S2, S3, where it would say hello, okay, or nothing.
Like that. Yeah.
So in between every element that you want to print out, you have to have plus signs.
If you want to concatenate, you need plus signs, right? So you can't just print line I space J. It'll compile complain.
So, I mean, this is more compact, but we could also do like another line. Like, is there a way to do not a new line?
Yes.
To have another statement?
So if you just say print instead of print line, it suppresses the new line at the end. Mm-hmm.
So if I wanted to have an output statement that adds two variables that I would have to make a third variable to store the sum in? Because
No, you can do parentheses.
Okay.
So if you say something like,
Okay.
that'll trick it.
So is it just like C where typically parentheses take precedence?
Yeah, by and large. All right, this is object-oriented code now. Okay, we have these objects S1, S2, and S3. Okay, think for a while structures in C, but we're going to get away from that eventually. String uppercase S is a type of variable. It's what we're going to call a class. S1 is a variable of that type. That's what we're going to call an object. So that's probably worth writing down. So string is the name of a class. S1 is the name of an object of type string. It's also called an instance of that class. So in some ways, classes are kind of like blueprints. String is a blueprint for an object of type class, but it's not an object in itself. Okay, S1 is an object of type string. It's been made from that blueprint.
So do they get away from calling it a data type just because a string holds more than just like a single thing?
Yeah, because these things hold not just data, but also code.
Okay.
So
And
data type would kind of like not
you
catch
can
it all.
invent new classes.
And you can invent new classes, and that's what we're doing in here. Right, so let me show you what a new class might look like. Okay, so here's my class test. And I'm going to create two variables, C1 and C2 of type my class. Yeah. So if I try to compile my class test, .java, it's going to complain that it does not know how to access my class. Okay, so there's no my class.java. I mean, there is, but it's just garbage right now. So let's make a class. Well, I mean, there's a class. It's rather uninteresting. But it'll let me compile it just fine. and it'll let me, my class test, it'll let me execute it, but it doesn't do anything, right? Because all we're doing is constructing two objects of type my class, and nothing much happens. But we're skipping way ahead here, so we'll do a lot more detail on this down the road. But let's tell it how to create a new my class, because typically we're going to have some variables and we're going to want to do some initialization and so on. So I don't know, let's get some variables in here. We'll do x, y, and z. And if I'm in a class called my class and I make a function called my class, that's what's called a constructor. And when I say make a variable of type my class, it's going to look for a constructor. It's going to look for a function named my class, and it's going to execute whatever code is in there. Now, let's not get too weird. So let's give these things some values. And I'm going to make everything public. And we'll talk about public, private, but basically we want everything to have access to everything else. Okay, my class C1, I'm telling the system C1 is going to be an object of type my class. But it is not yet an object of type my class. That's my intent for it. It's like saying integer star x. X is going to point to an integer, but it doesn't yet. Now, we don't have pointers in Java. That's part of the security enhancement of Java over C. There's no pointers. There's no direct access to memory. So we don't generally get seg faults and things like that. But that stuff is still happening underneath the top layer. Okay, it's still happening inside the JVM. So this says C1 is an object of type my class. But if I want to actually create a C1, I have to construct it. So I'm going to use the keyword new that takes the place of malloc. But I just say, give me a new my class, and take that newly created object, call that C1. And now I can say something like, let's look at C1.y. That's one of the fields inside this object. Right, so my constructor should set y equal to 20. And so I can say, let's print out the value of C1.y. And so if I run it, it tells me C1.y is equal to 20.
So you initialize variables outside of the constructor and then assign values to them inside the constructor?
You don't have to. You could do it any way that you want.
So you could do nothing outside of the constructor?
Yeah. In fact, in here, I gave them values inside the constructor. But I declared them up here. Now, if I had declared them inside my class, they're local to my class. And if I do that, it's going to tell me there's a bunch of errors. I don't think it liked the word public. But mainly it's going to tell me that there's no field y, right? So it can't find a variable y inside C1. because in the class called my class, there's no variable declared y anywhere except inside this function, which makes it strictly local.
Not to get too deep into public and private, but if you made all those variables public, does that make it available for all the constructors within that class or other classes?
It's with, yeah, it gets a little
That might be-
deeper.
that might be too complex.
Yeah. All right, so try your lab one, try your ODP, shoot an email or discussion group if the ODP is giving you problems, and we'll dig deeper into objects on Wednesday.
You may have to initialize the rest of those.